In this video, we're going to take a look at rotations and solids of revolution. In other words, how can we take a two-dimensional shape and rotate it or turn it in order to generate a three-dimensional figure? Let's go ahead and get started. In example 1, it says that we're going to take a rectangle whose length is 5 and whose width is 2, and we're going to rotate it or turn it around line L in order to form a cylinder. They then want us to find the volume of this cylinder. I think the thing that's the most important to pay attention to with these rotations is what line we're turning these figures about. That's important because, like when we did rotations back in the transformations unit, that line that we're turning this figure about is the line that's going to remain fixed and not move anywhere else. So in this case, this line L, which represents our line of rotation, is going to remain in place, and everybody else is going to turn around that line. So in other words, our rectangle is going to kind of envision this as coming out off the page at us, then lying flat across line L on the other side of the page, and then continuing to turn so that it's going into the paper, and then finally coming back to lie at rest where it began. So in other words, it forms this cylinder with these circular bases on the top and the bottom. And notice that the radius of our cylinder is 5, and the height of our cylinder is 2. Now, if you have a hard time envisioning that, you're not alone. I'm going to show you a little animation now of rotating a rectangle around a line in order to form a cylinder. The orientation is going to be a little bit different than our example, but the idea is still the same. So in this picture here, we have this rectangle, and we're going to rotate it about this line here that's at the center. So that's going to be fixed, and the rectangle is going to turn or spin around that line. So if you can see, it's coming out of the page towards us. Now it's lying flat, going back into the paper, and then lastly coming to rest exactly where it started. And it generates that cylinder. So again, that's kind of the image that we're trying to have you obtain in your mind's eye as you're seeing these solids of revolution. So again, if I go back to my example now, and I think about that rectangle coming out towards us, then lying flat, then going back into the page, it might make it a little bit more clear to see that that radius is 5 and that height is 2. So if we now want to go and find the volume of this shape or the volume of this figure, we know that for the figure that is created is the cylinder. And we know that the formula for finding the volume of a cylinder is V equals pi times r squared times h. So when we go to substitute into this formula, our radius now is 5, and our height is 2. This I can almost do mentally. 5 squared is 25. Multiply that times the 2, and I get 50. And it does not ask me to round, so I'm going to leave this in terms of pi. So 50 pi cubic inches, or 50 pi inches cubed. So either one of those is enough to get the job done. All right, moving onwards now, we're going to take a look and see what happens when we kind of perform the same exact idea, but our starting figure in this case is going to be a right triangle. And again, if I think about this in terms of what this means to rotate it, it's really, really, really important that we pay attention to exactly where it is that we're rotating around. So we're rotating this triangle around the longest legs. So if I look at this picture, one of the legs in this picture is 5. This other leg is here in purple. We don't know it. In order to be able to determine which one of those legs is the longer of the two legs, we're going to have to go ahead and do some Pythagorean theorem. So I'm going to do a little a squared plus b squared equals c squared here. So I've got x squared plus 5 squared equals 9 squared. When I subtract 25 from both sides, I find that our x squared is equal to 56, making x the square root of 56. I'm going to go and erase x from that picture, and I'm going to replace it with square root of 56. And now my two legs of this triangle are the red one and the purple. Square root of 56 is greater than square root of 5. So square root of 56 is going to be the line that we're going to rotate around. It's going to be the line that stays put, that doesn't travel anywhere new. I might make that dotted and solid. Now again, if I think about turning about that pink line, I'm going to think about the bottom of this triangle lifting up off the page towards me, then going back and lying flat on the page again, then continuing to turn so it's going into the page, and then lastly coming back to rest where it started. So in other words, in this case, we're generating a cone. The radius of our cone is 5. The height of our cone is that square root of 56. And again, if you have a hard time envisioning this, here's a nice little animation with that right triangle. In this case, too, they're going to rotate or turn that right triangle about the longer leg. And watch what happens when I start that animation. It comes up off the paper towards us. It goes back and lies flat on the page, goes back into the page, and then lastly comes up to repeat its rotation or its revolution. So there's the nice cone that's formed when that right triangle is turned about its longer leg or spun about its longer leg. And animation for me really makes it seem all the more real. All right, so going back to our problem now, they want us to find the volume of this cone. Well, first they want us to sketch and identify the solid. So the solid is going to be that cone. The radius of our cone is, of course, that 5. And the height of our cone, square root of 56. And then now find that volume. So just be careful here and make sure you use the correct formula, because we've had a lot of different formulas in our work with finding volumes of figures. You want to make sure that you use the correct one. So for a cone, our formula is volume equals 1/3 times pi times radius squared times height. So now I'm going to go ahead and I'm going to substitute in. I've got 1/3 times pi times 5 squared times the square root of 56. This didn't say exactly what to round to. I think we're going to, in order to simplify matters, we're going to round this to the nearest cubic centimeter. It's a little messy to read this one in terms of pi. So I'm simply going to get my calculator out and I'm going to start multiplying. I'm going to multiply 1/3 times the pi button on my calculator times the 5 squared times the square root of 56. And when I multiply all those or put those all into my calculator and multiply it out and round to the nearest cubic centimeter, I end up with 196. And again, I can either make this cubic centimeters or I can make that 196 centimeters cubed. Either one of those says it all very nicely. All right, good job with this one, folks. I'm going to have you go ahead and Generate your key ideas and see if you can apply what you've learned in order to solve the problems on the next page.